Hi everyone, welcome to my video series on categorical encoding. This is the third part. If you haven't watched the first two parts, please go and watch those two first. The first part, I talk about the one-hot encoding and label encoding. The second part, I talk about the target encoding and count encoding. Now I want to talk about the one that you're all very excited about, categorical embedding. I have seen a lot of videos, I have seen a lot of articles in the internet about categorical embedding. I'm not saying they are bad, but to me, it seems that you will still have a lot of questions after those videos are over. It seems to me that they are not really practical, or they don't really tell you what categorical embeddings are. Okay, I'm trying to actually solve that confusion in this video and tell you what exactly we mean by categorical embedding. All right, so the categorical embedding, the history about that is coming from the natural language processing, and it's coming from the word embedding. So in the domain of NLP, or in the language, so you have sentences which you make it like a token or word, and now you have to represent it. You have to represent this word in such a way the machine understands, in such a way that machine understands. But machine only understands numeric values. Machine doesn't understand a string or categorical values. All right, so people have tried different techniques that I discussed in the last two videos. People definitely thought about label encoding, definitely thought about the one-hot encoding, but then they reached to, and they definitely tried the mean encoding, means target encoding, and also count encoding, frequency encoding, hashing, and other different techniques. However, they all have a problem. One is that dimensionality problem. Since we have so many, since we have so many categories, right? You cannot do one-hot encoding here. How many different words do we have? You cannot add billion different columns here. And then another one is a semantic, or the meaning. Neither neither label encoding nor one-hot encoding and target encoding, count encoding, or any technique you have in your mind will consider the semantic or meaning of the word into the consideration. We talk about target encoding. It just look at the average of the target variable in that category and assign it to that category. So if two categories have the same average target, they get the same importance. That's really bad. It doesn't take the semantic of the or meaning of the word into consideration. All right. So for that, we need to come up with a different technique. In natural language processing, we have something called word embedding. Right? And the techniques for that, you guys have perhaps heard of the BERT, bidirectional encoder representation transformer, right? And the variation of BERT. Perhaps you have heard of GLOB, word to vec, GPT, many different things. Right now, ChatGPT or GPT are really becoming very famous for the language models, right? But these are word embedding when you have a sequence, when you have a sentence. In this video, we are invested on something else called categorical embedding, which the concept is very similar. So categorical embedding is mainly is a study of representing categorical features for tabular or a structured data set. You see, for example, this embedding can be later on used by XGBoost or LightGBM or a random forest, right? But it's for these, we don't have a sentence, we don't have a sequence. It's not a word embedding. So the idea, the practice we do is very similar, but we need to differentiate between these two concepts. All right. So now that we understand this, how do we do this? And what's the meaning of this categorical embedding? So the meaning of categorical embedding is a way, it is a way to represent a discrete categorical variable by dense continuous representation. Dense continuous vector representation. Okay, so that's what we call it, categorical embedding. We take this discrete categorical variable and we represent it with a dense continuous vector representation. All right, so let's take an example here, what we mean by this. So it's a vector, we are going to represent it with a vector. All right, so let's take an example. A good example that I want to take is the state. All right, or let's go with the state that are used in different videos as well. Let's go with the, let me not represent it like this. Let's go with the state. We have some states. We have California. We have Arizona. We have, I don't know, let's say New York. We have Utah. Utah. We have, I don't know, we have Texas. And let's say we go with one more state. I'm trying to sample from different location. For example, if we can sample from different location, all right, I'm gonna type this one, but let's say we have Alabama here as well. Some of them I type it, some of them doesn't matter. Alabama. All right. So now here the question is that, hey, I want to encode these states. All right, so the dimensionality is not huge here. You can say that, hey, I can do one-hot encoding. I can do label encode is bad. But I can do one-hot encoding. I can do target encoding. If I give you the target variable, I can do count encoding as well. But we have a lot of states, 50 states. And we don't want to do one-hot encoding and stuff. So I just want to actually make the point across. What do we do during the one-hot encoding? During the, sorry, not during the embedding, categorical embedding. What we do is this. At step one, create the integer representation of categorical variables. All right. So this integer, it can be like label encoding. So what I mean by that is you do this. California becomes 0. Arizona become 1. New York become 2. Utah become 3. Texas become 4. And Alabama become 5. That's what we do. First, we do this one. Then we are going to go ahead and map these numbers to a vector, to the dense vector. To which dimensional vector depends on us. And that's actually a parameters that you decide. All right. So let's say that you want to say that this 5 dimension, this one that we have 5 categories, I want to represent it as a 3-dimensional vector. All right. So what's going to happen here is that each word each category is going to be represented by a 3-dimensional vector. For example, California is going to be 0.1, 0.3, 0.65. Arizona become 0.9, 0.2, 0.33, and so on and so forth, right? So in a sense, we're gonna represent California, Arizona, New York, Utah, Texas, and Alabama by a vector of dimension 3. Each one has a dimension 3, and depends on how many we have. So here we're gonna have actually 5 by 3. All right. So we're gonna have 5 by 3 vectors, and that's what we're gonna have the initial embedding. So 5 by 3 matrix as initial embedding, right? So that's the first part that we do. It's the initial. Then what's going to happen here is that we repeat this procedure for all other categorical variables. For all other categorical variables. Then we concat all these categorical variables, or I have to use features. We are in the domain of machine learning. Along with all the continuous one, along with the continuous and numeric features. All right. Then we perform the training. We perform the training of the model. All right. So it's gonna be like this. Numeric features. Or categorical features by embedding. Encoded and that's a target. And then we make a training using neural network. Most probably using neural network. Later I will make a video and show you how you can do it using another model as well. All right, using neural network. Then what's gonna happen here is that during training process, using back propagation, the model adjusts the weights and parameters and learn the optimal embedding. All right, learn the optimal embedding. So that's what we call it categorical embedding. Why? Because actually it's the way to represent the categorical variables using continuous vector representation. Why is that good? Is because we actually get to find the optimal representation by the virtue of neural network or the virtue of the machine learning, supervised machine learning training. So let's talk about pros. The pros is that learn the relationship between categories. It does not add high dimension to feature space, regardless of regardless of number of categories. Right? You have 2,000 category. I can choose the embedding size to be 20. That's it. Can be very efficient representation for both nominal and ordinal features. It learns the embedding such that we can perform meaningful arithmetic on them. That's amazing, right? So you learn the embedding. I've seen that, for example, embedding of the king and embedding of the man, embedding of the woman, embedding of the queen. And then people say that, hey, if you subtract the king, for example, minus man, for example, plus woman, you get, for example, a queen. That's very, very efficient representation. So in a sense, you actually get a meaning to the representation that you have. You never get this one in any of the other embedding that I discuss and any other embedding that you will see in the literature. Okay, the cons of that hard to implement, requires extra steps for training. And the third one, which is very important, requires to assume the embedding size. Remember, you have to decide the embedding size beforehand, and then we have to do the training. So it's harder to implement. There are some domain knowledge involved for that. As opposed to the other four that I talk about that, this is definitely the hardest one to implement, but definitely the best one. Definitely the best one. In the word embedding, this is a must. In the world of natural language processing, this is a must. In the world of categorical variables, you can try the other one. And if you are not really happy, or if you have a reason, for example, so many categorical variables and so many like with a large cardinality, then definitely this is a way to go. All right. So there are a lot of stuff I want to cover from the categorical embedding, but perhaps I will cover them in the other videos. This video is getting actually too long. That's it for this video. Please, I assume that you guys might have a lot of questions about that. Please leave a comment, and I do my best to answer your questions. If you like this video, please like and subscribe to the channel, share it with your friends, and I will end this video right now, and I see you all in the next video. Thank you so much, and bye.